Okay, this is a Hillrom hospital bed that we're looking at right there. And they're pretty interesting mechanisms. I kind of like that they're highly actuated with feedback controls, and you'll see the certain different shapes they'll get into. I like this picture too. I wish it was a little bit more centered and you'd see that lower mechanism. But basically we're going to build this mechanical design very rapidly using this tool called Working Model 2D. You'll see that I did some practice and I already got this to work, and I think this will probably take us about 10 minutes to build this model. All right, so let's get started. So I'll open up a blank model. Okay, I'm going to do this lower kind of like bed frame. Think of it as the piece that'll have the wheels on it and all that kind of stuff. Not sure I'll put the wheels in yet, but anyways, this Working Model 2D, the 2D is an advantage. The advantage, you might think of as a limitation because it doesn't move into the three spaces, but it's way, way easier to build mechanisms, and most mechanisms are two-dimensional in nature anyway. So anyways, it is a mechanical simulator itself, and by default, gravity will act downward. All right, so if I select this whole thing, you'll see that the geometry that kind of defines where it is and what its shape is all readily available, very easy right here. And so I'm going to put in the proper dimensions. We're going to make it 0.1 meters in height, and we'll make it 2 meters long, so about the length of a human being. Probably in real life these are a little bit bigger than that, but 2 is a nice easy number. Now, when I zoom extents, that kind of includes the canvas origin, and it's just kind of in general a good idea to take advantage of something like a 0-0 position. And so we're centering the center of mass of this right there. And so now when I do zoom extents, it's nice and available for me right in the center of the window. I'm going to reduce it a little bit. I'll increase it a little bit too. All right, and hit run. It still falls, but we'll anchor it. So just kind of click it right there. All right, and so the mechanism is really about kind of moving this bed frame relative to this. Right, and so I'm going to again use a rectangle for that. This time I'm going to make it 0.2 in height and 1 meter in length. Let's take advantage of our symmetry, put it at 0-0, and let's put it at a height of 0.8. And we'll make this orange. Okay, so let's get those legs in. Use a slightly different shape this time. We'll make the dimension of that bar 0.1 in this direction, and we'll make it 0.8 in its length. All right, and so let's change the angle. That's radians, so I prefer degrees. And then I'll just type in a 60. And that looks pretty good. And so I'm going to just kind of drag it to what I think is going to be a pretty good position for this. Kind of like that. And let's put in our connections. And so it's going to be pinned up here. Think of that as like a hinge or a revolute joint. And here will be kind of on a slot. All right. And we'll hit run. And it's all working pretty good. Now by default, these parts will collide, which is a great feature, but we can choose for them to, collide or overlap, and by default I think I'll set it up so that all new parts will come in without collision. And with that, that's where we are now. Okay, so again, this lower mechanism, it's kind of, oops, I didn't mean to move it like that. Let's undo that move. Right mouse click. It's really kind of our goal now is just duplicate the same thing on the right side. And let's reverse that angle. minus 60 on this side. And I want to get this positioning right. Now this is a position reference to the center of mass. And let's see, got my glasses on. Minus, well, let's just copy it. Control C. Let's paste that in. And let's get rid of the minus sign on this side. All right, and the height's the same, 0.37 and 0.37 on each. Okay, so now it's really just going to duplicate that. Connections. All right, let's see, so how are we doing here? So we did put in the mass. No, we did not. All right, so the mass of this could be 20 kilograms. So that's a moving part, and it's kind of the essential moving part. So it's very important to get that right. And so anyways, assigning mass, of course, is pretty easy. All right, and I think we're ready now to, well, let's hit run, just show you what it looks like right now. Okay, let's put the bed in. All right, and so the bed's really the bed and the bed frame itself, and you know, of course, it needs to be compliant so it can kind of respond to the actuation. And so let's make that 0.1, and we're going to make the width 0.4. All right, and let's make the mass of this. Notice it's selected right there. Make it 5 kilograms. Put right adjacent to the bed there. And I think the last thing I'll do is go to appearance, and we'll make it in olive green. All right, and let's make sure that it's centered. So move it slightly to the right, and that's pretty good. And so now let's construct the other 3 bodies that will make up the overall bed and bed frame. Okay, now on the right side, it's going to support kind of the back and the head, and so again, I actually kind of prefer down here, 0.8 meters long. Put that right there. Let's duplicate this again. Put that right there, and we'll duplicate it one more time. Okay, and if parts are nice and adjacent like this is kind of a nice feature. You can just kind of quickly come in and put the joints in, and I'll double click on it this time, and that'll allow me to keep on using the tool to get those other 2 in. And the connection with the bed, now these are going to allow rotation. And we can kind of see that, I think, if we hit run. All right, not real well. And that, in a way, motivates our next thing is let's connect the bed to the orange piece, whatever we're going to call that. All right, and at this point, I think we kind of got everything. Let's hit run, and you know, obviously, we need motors and controls, and we wouldn't want flopping around like that, but you know, that's kind of why we're doing this. All right, and so I'd say it's really, let's get the actuators in next. So. And we're going to put in 5, so again I'm double clicking on the tool, and this one I think I'll connect like that. This one, this one, I think I want to be a little bit more on the far end, and then finally we'll put in a couple controlling the pink legs. It's through this that we're going to essentially adjust the elevation as well as the tilt. All right. And I want to be a little bit precise on these points down here, these connection points. So I'm selecting them. You're going to see them show up right here. And on the left side, I think I'm going to make it minus 0.3. Moves it a little bit more inward. And on this side it'll be 0.3, and all that looks good. And I'll hit run, and again, it's kind of a big mess, but we're in the middle of this, and we're getting a lot done very rapidly. All right. And so what I want to do now also, though, is let's take all these actuators, because they're not going to be just, random forces. They're going to be controlled forces. In a way, that means they're going to operate like real kind of length controls. And so on the actuators, selecting all of them at the same time, we're going to change the type to a length actuator. All right. And so that means they're going to hold these lengths, these positions. All right. So that's not good, but it's actually good that the tool revealed to me, one more piece we're going to put in this. And actually, we went back to those pictures we were looking at before. This image, or this component, really does exist. And so what we're going to do is put in this additional link. Oh, I guess I like that, 0.05. I think it might be a little bit longer. I'm going to make it 0.6. That looks too long. Let's make it 0.5, half a meter. Right. Make it purple, and we'll rotate it minus 60 degrees. And that looks pretty good. Right, and so this needs to be pinned right up there and right down here. Right, and hit run, and it's no longer flopping around. So we're really quite close. Right, and here's where, at least for this demo, MATLAB's going to come in. Right, and you'll see that we made all these length actuators, and you'll see that the length itself got automatically calculated for us by the tool, by essentially measuring the distance between the two attachment points. Well, we want this to actually move during our simulation. We want it to extend, like real actuators, right? And there's a formula language that's kind of based on all kinds of things that are observable in the model, but in this case, we want it to be with regard to time. And I realized, this is kind of a good opportunity to do this with MATLAB, right? And so I wrote this little script. You'll see it right here. I'm doing these calculations of trajectories, and we're going to do these little smooth transitions. And we'll see why that's important as we kind of get into this. But it's this idea that we'll take that initial length, and that this one we want to extend. Let's move this out of the way. And I want the delta on this one, to be 0.25 meters, about that distance. All right, and all I got to do is hit run, and it'll do the calculation for me, and we'll see the new shape right there. Oh, see, it's good that I looked at that. That is not a good starting time. Let's make it 1. Oops. And let's recalculate. And down here is that formula. So this is essentially working model 2D formulation that was written by MATLAB, and I just copy that output and I paste that in. And I hit run. Comes up nicely. All right, and so now I'm going to just kind of fill in the rest. So I'm going to edit after, and we'll have a little bit more shorter video. So let me do that. Okay, so on this last one, we're going to actually shorten the actuator. So I put in minus 0.1. Let's do the calculation. We'll see that shape that reduces it. And let's copy the formula again. And this is for that actuator. And I just paste in the formula. All right, pretty cool. All right, and I'm going to finish this by just doing a couple of measurements. I think could be any one of these actuators will be important. Obviously, in real life, you will want to know the force required and the speed of each of those actuators. But let's go ahead and choose that one. Right mouse click, we'll measure tension. And I thought it'd be kind of cool. Let's get the bearing load on that joint right there. Measure. Select it again. So on that force. Okay. Set these each up so they'll be graphs. And we'll hit run. And we see those forces being calculated for us as it moves. All right. So if you've been watching my videos over the years, you know I do a lot with MATLAB and Simulink, and ultimately I bring these things into Simulink using SimScape Multibody, and I make that process really, really easy. That's the basic idea. And it begins by building a good mechanical model like this. So this is a new tool I usually use, a tool called SimWise, and just to give you a little bit of history, SimWise's original name was Working Model 3D. So we got Working Model 2D and 3D. It's a company I worked for in the 1990s, and it was a great time working for that company. These products are still quite good. So anyways, I'll save it for the next video. Plus I have a little bit of work to do to kind of make sure this all functions properly. But I'll show how you go from Working Model 2D to SimWise. And then again, I think there's loads and loads of content out there showing how SimWise brings you the mechanical models into Simulink using the tool SimScape Multibody. So thanks for watching.